Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai.
Welcome back, everyone. Today we're jumping into a 7th grade topic, simplifying factorials. Now, if you're new to my channel, I'll be putting time codes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions what we see today, or even your own homework, you can always put it in the comment box below, or visit me on my Facebook page at Tutor Me Sempai and tell me all about it there. At the end of this video, I'll be linking my 7th grade playlist, in which I cover a lot more topics. So if you're interested in that, make sure you stay tuned. This video will have 3 parts, so leave a like, smash subscribe, and let's get started. 2 quick things before we get started with today's examples. The first is, if you have no idea what a factorial is, I really recommend you don't jump straight into our simplifying and adding of these factorials, but instead figure out what a factorial is first. And to do that, I have a video you can find right up here in which I give you a nice introduction into factorials. So once you have a good grasp and a good handle on what a factorial is, come back here and you can see how you can add and simplify it all at once. The second thing is, we want to make sure that we're not just adding these, but we're focusing on simplifying these. Now, some of these easier ones, it may be easier to just add them. But as we get bigger and bigger and bigger, the focus really should be on how to simplify this into smaller terms. And you'll see what I mean later on. So now that we've gotten that out the way, let's jump straight into our example here. So we have 4 factorial plus 5 factorial, and we want to add this, but we want to add in such a way where we're simplifying this. Now, if you want to find the answer later, you can, but we want to really focus on simplifying this. So that means we don't want to just expand this out into 4 times 3 times 2 times 1 plus 5 times 4 times 3 times 2 times 1, and then find the answer. We don't want to do that. That's not really helping us simplify this. So how are we going to simplify? Instead of going down that route, let's figure out and think about what a factorial is and how we can make this a little bit simpler to look at. So we know that factorials are just going to be all the numbers from 1 up into whatever number is here multiplied together. Well, that means that every smaller factorial is going to be a part of a bigger factorial, right? So 2 factorial is part of 3 factorial. 3 factorial is part of 4 factorial, and so forth. Well, that's going to help us factor these factorials in order to simplify them. If 4 factorial is a part of 5 factorial, we should be able to extract 4 factorial from this expression. And in order to see that, we can write it like this. Instead of 4 factorial plus 5 factorial, we can say it's 4 factorial plus 5 times 4 factorial. Now, this is going to be the same thing as 5 factorial, right? Because if you were to expand this out, you have 5 times, in parentheses, 4 times 3 times 2 times 1, and that's just 5 factorial. So by rewriting it this way, we know that 4 factorial is indeed common with both of these, so we should be able to factor it out. And when we do so, we get what? Well, we're going to have a 4 factorial on the outside. What's left over when you factor a 4 factorial out of this? 1 plus what's left over here? 5. So 4 factorial times 6 is going to be our answer. Or you can rewrite this as 6 times 4 factorial. And you can leave it just like that. That's your simplified answer. Instead of having 2 factorials, we're a little bit simpler by just having 1 factorial. But how do we know that our answer has the same value as our original question? Well, you can always go back to this and figure out what the numeric value is. Then compare it with the numeric value of your answer to verify that they are indeed the same thing. We know that 4 factorial is just going to be 24. And we know that 5 factorial should be 120, which means that our answer should be 144. Now, we just have to multiply 6 times 4 factorial, which we know to be 24. What's 6 times 24? Well, it's 144. Therefore, these 2 answers are the same. Our final result has the same value as our original question. So let's jump into our second example. In this example, we have 7 factorial plus 9 factorial minus 8 factorial, and we want to simplify this. Now, the goal for these examples is to first identify what is the smallest factorial. Remember, every small factorial is going to be part of a bigger factorial. So we want to first start with the smallest factorial because that should be the one that they have in common, especially if you have more than 2. If you have 3 or 4 or 5, whatever, find the smallest and then we can extract that one. So which one is going to be the smallest factorial? Well, 7 is going to be the smallest factorial. So let's focus on extracting 7 factorial out of everything. But first, let's rewrite these so it's more obvious that we have 7 factorial in everything here. So this is going to be 7 factorial plus parentheses 9 times 8 times 7 factorial minus parentheses 8 times 7 factorial. Writing like this makes it really obvious that 7 factorial is in each one. Now we can safely extract it, leaving a 7 factorial on the outside and a big parentheses with a 1 here plus parentheses 9 times 8 minus 8. Now we do order of operations to focus on what's inside of parentheses, and we have a 9 times 8 here. So this is just going to be a 72 minus 8, and it's going to be a plus 1 over here, times a 7 factorial on the outside, and we're going to just keep carrying this down. 7 factorial, and what's 1 plus 72 minus 8? Well, this is going to be 65. So we can rewrite this as 65 times 7 factorial. So with this as our final answer, it doesn't look that much simpler, but we did reduce it from having 3 factorials to just 1. So remember, the first step should be identify what is your smallest factorial so we can work on extracting that out. But let's jump into our last example for today. So this is going to be our last example for today. And we have 3 times 5 factorial minus 7 times 8 factorial. Now, what do we do if we have some numbers already multiplied by our factorial? How are we going to simplify this? Well, we're going to tackle it the same exact way. Remember, we're already rewriting this so it has multiplication on the outside anyway. So we're going to do the same exact thing. First, we want to identify what is our smallest factorial, which we see is going to be this 5 factorial. So that's what we're going to focus on extracting. But first, let's rewrite this so it's more obvious that 5 factorial is in both numbers. So we're going to have 3 times 5 factorial minus 7. Let's put this in parentheses. 7 times this 8 times a 7 times a 6, all in parentheses, times 5 factorial. Now, this part here is what made up 8 factorial. And you had an extra 7 up here. So make sure you don't get confused and think that you already have your 7. This is supposed to have 2 7s. So now that we've written this out, let's extract our 5 factorial. We see it is indeed common to both of these. So we have a 5 factorial on the outside, and we have big parentheses. And what's left over when you extract a 5 factorial from this? Well, it's going to be 3. And we have a minus, and we're going to take this whole parentheses and throw it in here. We have 7 times 8 times 7 times 6. And that is what's going to be left over when we extract this 5 factorial. So focusing on order of operations, we're going to do this first because it's inside our parentheses, So what's 7 times 8 times 7 times 6? Well, this is going to be 2,352. And we're going to subtract it from 3. So this is going to be what's truly inside of parentheses. And remember, we're bringing down our 5 factorial on the outside. Now we have one more step. What's 3 minus 2,352? Well, this is simply going to be 5 factorial on the outside, 2,349, except that's going to be a negative. And we can rewrite this as negative 2,349 times 5 factorial. This is our answer. So you see, it doesn't matter whether you have pure factorials or if you have some numbers already multiplied to them. We're going to tackle it the same exact way. When you're adding or subtracting these, you want to first focus on where is your smallest factorial. If you can find that, you can extract it, and then you can simplify the rest. So I hope you were able to follow on to these examples, and I hope you didn't find them too confusing. However, if you did, remember you can always put in the comment box below any questions you may have had, or visit me on my Facebook page, @Tutor Me Sempai, and tell me all about them there. If you haven't done so already, remember to leave a like. It really helps the channel by letting YouTube know that you found a video helpful. And if you found a video helpful, so so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share this video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework. I'm looking forward to seeing you again next week. I'm Courtney, here's your playlist, and this has been another session of Tutor Me Sempai.